Hi everyone. Before we get started with the week 4 material, I just wanted to go over some changes for this week. All of the packets will now be the same for every teacher. So all the cover sheets are going to look the same if you do go to school and get one. So you're going to see all the teachers' names here, and then our Google Classroom codes are listed there. And then also the live tutoring times, any teacher that you want to go to is fine. If you're available when one teacher has tutoring and you're not available when another one has tutoring and that other teacher happens to be your teacher, it's okay. You can always go to another teacher's Zoom session if you need help, okay? Another change that I want to talk about is the way that we're going to be doing grades and assignments from this point on. So you have your calendar for this week up here. Monday, Tuesday, I want you to watch those video lessons and take notes. On Wednesday, you're going to see that there are problems that are labeled as practice in your packet. So I'll show you what you know kind of what you're doing. And then on Thursday and Friday, we want you to be working on the reflection questions. So there's a little schedule down here where it says upcoming changes for week 4 and 5 of how we're going to run things now. So on Monday of week 4, I'm going to post the new packet and the video lessons onto Google Classroom. None of that is going to be graded. That is just for you to get acclimated with the material. On Wednesday of week 4, the reflection questions will be uploaded and you will complete them on a piece of paper, and then you will attach that piece of paper to a Google form and upload it that way. These are going to be due on Monday of week 5. So they'll be posted on Wednesday and they'll be due on Monday of week 5. On Monday of week 5, you will turn those in, or you can turn in earlier if you want. A key to those reflection questions will also be posted on Monday. What you're going to do is, using the key that's posted, you're going to go back and fix any of the mistakes you made on your week 4 reflection questions. So you'll submit them either on Monday or prior, and then on Monday I will post the solutions and you will go back and check your work. There will be a second Google form where you will upload the original work that you did for the reflection questions as well as the corrected work, and you will upload those in a single PDF document into a Google form. So your grade, where it says to earn a C complete for week 4, is going to be comprised of 2 assignments each week. So you're going to have the original week 4 reflection questions that you're going to attach to one Google form. Do those on a piece of notebook paper and then keep it. And then the corrected week 4 reflection questions and the original week 4 reflection questions, you're going to mesh those into a single PDF, and then you're going to upload those to a separate Google form by Wednesday of that week. So Monday, you have the original reflection questions due, and then on Wednesday, you have your corrected reflection questions due. So that would be giving you 2 grades per week. It's going to eliminate you having to print out anything. You can still print the packet if you want to, but really all you have to do is the reflection questions on notebook paper. Okay, so let us know if you have any questions in regards to how the assignment and grading is going to work. Let's go ahead and take a look at the material for this week. So we're going to be looking at laws of exponents and laws of logarithms today. The first focus of this video lesson is just going to be laws of exponents. So if you're in Miss Serio's class, we made a foldable. You can take that out and use it if you want. It's the same exact properties that are on your foldable. This first page is just a list of everything, all the rules, so you can kind of use this as a reference sheet as we're going through everything. The next page is laws of logarithms. Just keep this in the back of your mind. The next video lesson is going to cover this. For example, right here, you've got this little box that says practice. On Wednesday, I want you to go through the packet and do the problems that are labeled as practice. The other problems I'm going to do in this video lesson. Okay, so let's try some. So the first thing we're looking at is the laws of exponents. Just to remind you, of the vocab, your base is the number, the larger number. By larger, I don't mean in value, I mean in size. And then the small little baby number that's at the top, that's your exponent. So you have base and you have exponent. So we're going to go through the different properties. So our first property is product of powers. The rule for it is right here. That means when you're multiplying the same bases, you're going to add the exponent. So for the first example, my base is 5. I'm going to add the exponents because I'm multiplying those two things together. So this is going to be 5 to the 2 plus 6. So I have 5 to the 8th power. If you want to type that into your calculator, you will get 3,90625. Okay, and that would be your answer. Okay, for the two that say practice, let's just hold off on those. You can do those. The one below it, you're still multiplying these together, even though you do not have a multiplication symbol in between. If you have two things in parentheses and no symbol in the middle, it still means that you're multiplying. So I'm going to multiply the numbers in the front first. So the 7 and the 6, I'm going to kind of break them into their own group. And then I'm going to do the same thing with the bases. So I've got y to the 5th times y. So the 7 times 6 is going to get me 42. And then this y right here, there's a 1 on it. We just don't write that there. So that would be y to the 5 plus 1. So we get 42y raised to the 6th power. Okay. On your practice problems for this section, this one right here, that's got the 3 letters, you're still just adding the exponents because the bases are the same. On this one here, you're going to do similar to what I did on the 7y to the 5th times 6y problem. Just break it into all the separate bases. And for all these practice problems, you can look at the completed packet on Google Classroom to check your answers if you want to do so there. Okay, for quotient of powers, that means that I'm dividing like bases, so I'm going to be subtracting the exponents. So let's look at our first one. This on the bottom, there's really a 1 there, so this would be y to the 6 minus 1, and this would be y to the 5th power. I can't put that in a calculator because I don't know what y is, so I'm just going to leave it as y to the 5th power. On the next one, the base is 6, and I'm going to subtract 13 and 2. So I'm going to get 6 to the 11th power. If you type it in a calculator, that's what you would get, but I'm sure that all of the teachers would take either one of those as a correct answer. Okay, we're just looking to see that you can do the correct thing with the exponents. On the practice problem for this section, just break apart the fraction into different pieces. So I'm going to do 10 over 15 is a section, a to the 7th over a to the 5th is a section, and b to the 9th over b to the 9th is a section. Okay, so section those off and then subtract exponents. Next, we've got the 0 exponent. That means that any number to the 0 power is 1. So let's kind of look at why that's happening. I'm going to start off with using the property that we had before, the quotient of powers. So here I have the same base, and the base is 8. I want to subtract those exponents. This is going to be 8 to the 2 minus 2. Add those together and you're going to get 13. So your answer here should be 13. Our next one is a negative exponent. So whenever we're writing exponents, we do not like them to be negative. We like to write them as a positive number. So I'm going to do the quotient of powers again for this example. So this would be b to the 2 minus 5, which is b to the negative third power. I don't want to leave that as a negative number. So I'm going to use that negative exponent rule to flip it. So I can really write this as something over 1. I'm going to flip the top and the bottom of this fraction, and then I'm going to make the negative 3 a positive 3. So we're going to have 1 over b to the positive 3. Okay, let's look at the practice problem for this section. So, or the notes problem, sorry, not practice. This one, that negative 3 exponent is being applied to the negative here and the 3 that's here. So this is different. This is not equal to this. Those are two different things because the negative sign's on the outside. If I want to simplify this one, remember this whole thing is over 1. I'm going to flip it. So this is going to be 1 over negative 3. And then I'm going to make the exponent a positive 3. So I'm not changing the sign of what's in parentheses. I'm only changing the sign of the exponent. So this is going to be 1 over negative 3 times negative 3 times negative 3. So if I multiply 3 negative signs together, it's going to come back negative. And then if I multiply 3 times 3 times 3, that's going to get me 27. So you can either write it like that, or we can have negative 1 over 27. So it's okay for my overall answer to be a negative number. I just don't want the exponent to be negative. Okay, let's look at power of a power. So that means that I've got a base inside of parentheses that has an exponent on it, and there's an additional exponent on the outside. What you're going to do in that case is multiply the exponents. So on our notes question, this is going to be y to the negative 3 times negative 4. So negative 3 times negative 4 is a positive 12. I don't know what y is, so I'm just going to leave it like that because I can't evaluate it as an actual number. Okay, now let's look at power of a product. So that means that you have two things being multiplied together on the inside of parentheses. The exponent that's on the outside is going to be applied to both of those numbers. So let's look at this example here. That exponent of a 3 is going to be distributed as an exponent to each of those pieces. So this is 4 to the third power, x to the third. Since I have a 3 that's inside the parentheses and outside, I'm going to multiply those together using the rule that we just did. I'm going to have y to the third and z to the third. So when I simplify this, 4 to the third power is 4 times 4 times 4. So this is going to give you 64. X to the 3 times 3 is x to the 9th power. Then I've got y to the third power, and I've got z to the third power. None of these bases are the same. X, y, and z are different letters, so I can't simplify this any further. So I'm just going to leave it like this. Okay, on the next one, same thing. I'm going to distribute that negative 2 as an exponent to all of the pieces. So this is going to be 7 to the negative 2, x to the negative 2, y to the negative 2 times negative 2. Negative 2 times negative 2 is a positive 4. So at this point, my problem is I have negative exponents right here. We don't want to leave those as negative exponents. So we're going to move them to the bottom of the fraction. So right now, all of this is over 1. I want to take this, and I want to move them to the bottom of the fraction. So the y over 4, or y to the 4th, is going to stay on top. On the bottom, I'm going to have 7 to the positive 2 and x to the positive 2. One more step. 7 squared is 49. Okay, so once you've simplified all of that, that is your final answer. My hint for the practice problem here, remember that the part that says z to the 0, remember that any number to the 0 power is 1. So do that, make your life easier. Okay, next we've got power of a quotient. So that means you've got two things on the inside of parentheses that are being divided and an exponent on the outside. It's kind of similar to the power of a product, where that exponent gets distributed as an exponent to both pieces. So I'm going to distribute this. So you're going to have 3 squared over 5 squared. 3 squared is 9, and 5 squared is 25. I can't reduce that fraction any further, so that's my answer. The one below it, I'm going to distribute that 3 to every piece that's there. So I'm going to have 3 to the third power, a to the negative 4 times 3, over b to the 7 times 3. So if there's already an exponent there, you're multiplying. So 3 to the third power is 27. This is going to become a to the negative 12 over b to the 21. Okay, now I've got this negative exponent of a negative 12. I want to move this term to the bottom of my fraction like I did on the other example so that it becomes positive. So I'm going to have 27 on the top. On the bottom, I'm going to have b to the 21 and a to the positive 12. A and b on the bottom are not like bases, they're not the same, so you can't do anything with those exponents. So this would be my final answer. Okay, last one for this section. I'm going to distribute that 2. So we're going to have 2 to the second power, a to the 5 times 2, and b to the 7 times 2. So 2 to the second power is 4. This is going to be a to the 10th over b to the 14th. So on this example, there are no negative exponents and there are no more like bases, so this would be my answer. Okay, let's take a look at rational exponents. So looking at this formula here, sometimes you want a base to have an exponent that's a fraction, and sometimes you might want to rewrite it into a radical form where you've got like a square root symbol or a cube root or a fourth root or something like that. So let's start off just simple. I want to rewrite these in the opposite form. So if I have x to the 2/3, right now this has an exponent that is a fraction or a fractional exponent. I want to change it into being a radical form. So I'm going to use the formula. Here my m is equal to 2 because it's the number on the top of the fraction, and n is equal to 3 because it's on the bottom of the fraction. So I'm going to change this using the formula that I colored in red. My a, sorry, I'll put an x, goes inside. The letter n goes on the outside of the radical, so 3 is going to go on the outside of the radical, and the letter m goes above as an exponent inside the radical. I don't know why I wrote m. I'll rewrite it. So this is 3, and this is, my m is 2. So that would be rewritten in radical form. Okay, let's try another one. So here on this problem, the 2 that's in the front, that is not inside the radical at all. It's completely outside of it, multiplying the number that is in the radical. So I'm going to rewrite this into a fractional exponent. So I'm going to have a 2, and then I'm going to rewrite this as x to the 5 over 6. So the 5 that's here, that's inside, goes on the top of the fraction, and then the 6 that's on the outside goes on the bottom of the fraction. So at this point, I really can't simplify it any further. I can't multiply the 2 and the 5 over 6 because one of them is a constant that's like a coefficient, and one of them is an exponent. So I can't multiply those two together. So I'm just going to write this as 2x to the 5 over 6. and that 5/6 exponent is only being applied to the x. It's not being applied to the 2. Okay, one more. I want to rewrite this. This is currently in radical form. I want to change it so that it's a fractional exponent. So this is going to be x. My number inside the radical, the 4, is going to go on top of the fraction, and the number outside the 2 is going to go on the bottom. I can actually simplify this one. 4 divided by 2 gets me 2. So written in a fractional exponent form, or in this case it reduces to a whole number, we get x squared. That is the end of our video lesson. The next video lesson is rules of logarithms. So at this point, you can either stop watching the videos and go ahead and try those practice problems that are labeled, or you can watch the rules of logarithms and then do all the practice problems together. It's up to you, whatever you want to do. Let us know if you have questions.